So you've seen this function before. This is y equals e to the x, and the derivative of it looked exactly like y equals e to the x. And we talked about it that this is the only function that this ever happens with. The derivative is itself. So you can see that this graph has a positive slope that's increasing. So the derivative would be drawn above the x-axis and it would be increasing. So the graph is itself. So the derivative with respect to x of e to the x is e to the x. Now, if we switch this with respect to u, the derivative of e to the u would be e to the u times du dx, or e to the u times u prime. Now, you'll see that I rewrote it one more time, u prime times e to the u, and because that's how we all write it. We move the u prime to the front. So if we had e to the 2x, u would be 2x, and the derivative of 2x is 2. We don't write e to the 2x times 2. It just looks awkward. We would write 2e to the 2x. So some things to know about this function. If I take the limit as x approaches infinity, I'm going to get infinity. This graph goes up forever. So as you head to the right, the graph is hugely tall. As I head towards the left of e to the x, I am actually approaching a y value of 0. There's an asymptote on the x-axis. So I'm headed towards a height of 0 as I head towards the left. Now, if I was to describe the first derivative of this function, I would say that it's positive. So the graph is going up from left to right. The first derivative is positive. In fact, the original function, this is important to know, is always positive. So if you ever have to plug something in and you're wondering, is it positive or negative? It's positive. It's never negative. The second derivative of this function, well, the first derivative wasn't just positive, but it was increasing. So the slope of the first derivative was positive, and the second derivative is the slope of the first derivative. So the second derivative of this function is also positive, which I can tell by looking at the graph. And this is something that I'm going to start mentioning in these now, and pretty soon we're going to talk about it for real. But this graph is concave up. Concavity goes with the second derivative of a function in terms of positive or negative. So if the second derivative is positive, then the graph is concave up. If the second derivative is negative, then the graph is concave down, and that goes both ways. So since this graph is concave up, I know the second derivative is positive. It is the slope of the slope. So describe the second derivative, I would simply say it is positive. The first derivative, you could say positive and increasing, and that's how I know the second derivative is positive. The original function is positive, increasing, and concave